right, class, here we go. We're doing lesson 1.4, but let's take a look at warm-ups. So from last night's homework, ladies and gentlemen, probably one of the hardest questions, they were starred as being a challenge question, is number 16 and 17. The difficulty here, guys, is that although they gave us a function, yes, f of x equals x squared plus 2x minus 15, they didn't give us the x value or the independent to sub in. They actually gave you the dependent, which is the y. So in this case, guys, just think y equals 0. So what are we going to do? We're going to sub in y equals 0 and solve for x. So basically you're doing your factoring, okay? So remember, this is trinomial factoring, so you need your product and your sum, and your product equals a times c, so that's negative 15, and your sum equals your b factor, which is 2. Again, you find out what two factors have that product and sum, and your answer is negative 3 and 5. So again, you put in, because it's simple trinomial factoring, you put in your binomials of x minus 3 and x plus 5. And then remember, in order to use the zero product property where the left side equals the right side, so how do we know the left side equals 0? How do we get the right side to equal 0? We either let one of the brackets or both of the brackets equal 0. So you set them equal to 0, so the answer to this would be x equals 3 and x equals negative 5. Usually it's the opposite of what you see in the brackets, as long as it's in the proper order where x starts and it's positive. Looking at example B, ladies and gentlemen, same deal. Again, they gave you y, f of x equals negative 12. So just think, guys, that's y equals negative 12. So you substitute that in for y. And the only thing is, when we go to solve here, you take the negative 12, bring it over, and you add it to the other side.
Would Mr. White please call the office? Mr. White, please call the office.
Okay? So after we've taken that and brought it to the other side, we collect our terms. So we are at negative. Okay, sorry about that interruption, guys. Hopefully this recording's still working out well. I'm just new at this, so please have some patience with it. So I think we were over here at example B, guys, and we brought the negative 12 over, and you collected like terms. So when you bring it over, it becomes a positive. So negative 15 plus 12 equals negative 3. And then again, guys, you've got a trinomial here, so you take a look. What's your product? What's your sum in this case? Okay? So again, your product is a times c, 1 times negative 3, which is negative 3, and your sum equals 2. You may have been taught last year by m plus n or m times n, but most people seem to have the product and sum. So what two numbers multiply to negative 3 and sum to positive 2? So your solution that you put in the brackets is x minus 1 and x plus 3. Don't forget to use your zero product property where you let each of the brackets equal 0, or it's the opposite of what you see inside the bracket. So your solution here is x equals 1 and x equals negative 3. C is a similar case where, ladies and gentlemen, you're given that y equals negative 16. So you sub in y equals negative 16, bring it over, collect like terms. C value is now plus 1. And again, then you use your product and sum to recognize that that you get your factors of 1 and 1. Or you may recognize this as a perfect square, ladies and gentlemen. We'll be talking more about that in our classes coming up. But what you notice is when you have done the simple trinomial factoring that both factors are the same. So what does that mean? X plus 1 squared equals 0. So that means there's only going to be one solution in this case because both factors are the same, and it is x equals negative 1. Okay, moving on to 17, you're given two functions, the f at x and the g at x, ladies and gentlemen. Okay, and then what you needed to do is find out, does f at a equal g at a? So basically, the left side is your f at x function, and
Mr. Cook, please call the office. Mr. Cook.
I apologize, and your right side is your g at x function. Okay, so again, you're replacing, instead of x, you're replacing it with a's. Okay, so basically for the left side and the right side, and then all you do is isolate a, collect like terms, and you get a equals negative 1/4. The second example is a little trickier, where you have, instead of x, you've got x equals a squared. So subbing that in might be a little bit more difficult. And in this, in g at x, we've got x equals 2a. So again, we substitute those in, look to collect like terms. What's more difficult here, guys, is we end up with a trinomial, And does A equal 1 in this case? No, it doesn't. So this is what we call decomposition. That means you're going to split the middle term, and you're going to then factor by grouping. So again, product is A times C, which is -3. Sum is 2. And what two factors create that? -1 and 3.
Mr. Cook, please call the office.
What we're going to do there, guys, is we're going to split the middle term into two terms. So if you take a look at -1a and plus 3a, that equals 2a. It has not changed the value of the equation. We've just made it 4 terms instead of 3 terms. And then what we do, ladies and gentlemen, is you look at the first 2 terms, you say, hey, what can we common factor out of there? We can common factor out of a. What's left over after you common factor out? 3a minus 1. Group the last 2 together. What can you factor out of there? Only a 1, so you put plus 1, and what's left over is 3a minus 1. The purpose of doing this is hopefully that you realize that you've got now a common binomial. They're the same. So again, that becomes your factor here. So you're going to factor out the binomial, and then what's left over is a plus 1 to equal 0. And then what you do, ladies and gentlemen, is you let each of the brackets equal 0, and again solve for a in each case. This first bracket's a little more difficult, so I showed you the steps. So 3a minus 1 equals 0, move the -1 over, so you've got 3a equals 1, and then isolate a, divide both sides by 3, so a equals 1/3. And the second case, again, that's one of the more simple cases where you know it's the opposite of what's in the bracket. So those are your warm-ups, ladies and gentlemen, and they were tricky. Okay, let's take a look at today's lesson. Today's lesson is domain and range. The domain is a set of all possible values for the independent variable, or x. Okay, so think about domain relating to x, whereas the range, ladies and gentlemen, is a set of all possible values for the dependent variable, so think about y. Okay, so all I want you to do is think about when you're shifting left, right, up, down on your graph or doing transformations. The domain deals with the left or right movement on a graph, whereas the range deals with your up or down movement on a graph. Okay? Example 1, find the domain and range for each of the following. Notice here, ladies and gentlemen, this is a mapping diagram. And this mapping diagram, ladies and gentlemen, has points. Okay? So it's just ordered points. So in this case, you're going to have to list each of your domain and each of your range. Try to put it in, guys, numerical order. Okay? So please put it in numerical order. All right? And if a number happens to repeat, you don't need to write it out again. Okay? Looking at example B, again, ordered pairs can be listed differently. So looking at our x values in the ordered pairs, the smallest one is -5, -3, 0, 2, 3. And then, ladies and gentlemen, we take a look at our y values, okay? And our smallest one in the y is -3, and then we have 0, 1. And notice here, ladies and gentlemen, we have 2 3s. We have for the y. We have a 3 in the first one and a 3 in the fourth one. Since it's already included once, you only need to list it once. And I wrote that out here. Okay? So that's when you're given ordered pairs or mapping diagrams, you specifically tell each dot. Because if these were graphed or plotted, guys, it would just be a point on a graph. It's a little different situation when you deal with an equation or a graph. Okay? Taking a look at this quadratic, ladies and gentlemen, it's a parabola. It opens upside down. The maximum value is 3. Okay? And let's take a look at some new nomenclature here, folks. So the domain is such that x belongs to a set of real numbers. So this little e, or scripted e, means to belong to, and r that's bolded is a set of real numbers. So in this case, ladies and gentlemen, as we take the expression and go further down in either case, it's going to go further left and further right. So there's no restrictions as you go left and right. It can be any value for the domain. Whereas the range, ladies and gentlemen, the range is a little different. Along this parabola, folks, we can't go all the way up and all the way down the graph. We can go all the way down the graph because these arrows continue. But we stop here. We stop at the maximum. So let's read this. The range is y belongs to a set of real numbers such that, and that's telling us that there's a restriction, y has to be less than or equal to negative, what? Let me say that again, guys. Y has to be less than or equal to 3. So along my graph, as I move this up here, the highest I can get is to 3, and then I go back down and get lower. So that's a restriction. So whenever you have a restriction, you have a such that bar, and in this case, it's y is less than or equal to 3. Take a look at D, ladies and gentlemen.
The warning bell will go in just a couple of minutes. When that happens, students are asked to report to the period 1 class.
Okay, folks, I hope this pausing is working back and forth. It's hard to do a video and there's lots of interruptions, so thank you for your patience on this one. Okay, taking a look at example D, we have a circle. So this circle, guys, means that it can be anywhere along this line. Okay? And anywhere along this line means that if you take a look left and right, the furthest we can go left is to -5, and the furthest we can go right is +5. So how do we say that? We say that for our domain, x belongs to a set of real numbers such that x can be, and this is how you show it when you've got two restrictions, one on the left and the right. So you start in the middle. X has to be greater than or equal to -5, or x has to be less than or equal to 5. Taking a look at our range, ladies and gentlemen, again, that's our up-down movement. We start from the bottom. Again, the lowest we can get to is -5, and the highest we can get to is +5. And what we need to do is realize that, yes, x belongs to a set of real numbers, so we can have any number between -5 all the way to 5. So that's why it belongs to a set of real numbers, such that our lowest limit is -5 and our highest limit is +5. So again, it's y is less than or equal to -5, and y is y is greater than or equal to -5, and y is less than or equal to +5. In summary, ladies and gentlemen, to finish up here, in summary, when given a list of points, you list all the possible outcomes in numerical order. When given a solid line or a graph, you start with x equals x belongs to a set of real numbers, or y belongs to a set of real numbers, and then you state the restrictions. Let's pause for a second. All right, class, so thank you for that other pause. So here we go. We're just going to finish up domain and range. So when you have to find the domain and range from an equation, I want you to just visualize what does it look like, ladies and gentlemen. So when you have a function, f at x equals 2x minus 7, we have to think, hey, what type of relationship is that? And hopefully you realize, hey, there's no exponent, so therefore it's a linear expression. And when you have a linear expression, you can see that, hey, for example, we've got a straight line, which means you can always go left and right, and you can always go up and down. There are no restrictions on domain and range unless you have either a horizontal or vertical line. And it will show you that by saying x equals something like 5 or y equals something like 2. And in this case, if you've got the slope, like the y equals mx plus b part, then you will know that there's no restrictions. Example B, ladies and gentlemen, taking a look here, we have exponent of 2. Hopefully you recognize that as a quadratic, and it's in quadratic form. What does that tell us? First of all, it tells us the vertex is 2 and 5, and the -3 for the A tells us that it opens down. So hopefully you know with a quadratic that the domain is such that x belongs to a set of real numbers. There's no specific restriction there, whereas for the range, ladies and gentlemen, again, you have to look at your maximum. As you're on the parabola, the highest part you could get to is 5. So in this case, you write down y belongs to a set of real numbers such that y has to be less than or equal to 5. Taking a look at C, and this is a new function. This is called the square root function, and we're going to learn about this parent function in a class or two. Just remember, folks, that when you have a square root, that is actually exponent of 1/2, so it's another way to write it. And remember, when you're under a square root, ladies and gentlemen, that you can't have a negative value. So all we need to do is say, hey, what's under the square root? It needs to be greater than or equal to 0 because it can't be negative. So all we do, folks, here is solve within the square root to find the x value. And what we figure out is that x can no longer, x has to be greater than or equal to 2. So when we do our domain here, x belongs to a set of real numbers such that x is greater than or equal to 2. And what we will learn about the quadratic, the square root function is that the parent function starts like this, basically half of a parabola on its side. And when we learn about basic transformations, we'll notice that it just doesn't occur in the bottom quadrants. So it doesn't occur in quad 3 or quad 4. So that's why we say that y is going to be greater than or equal to 0. And again, we'll learn about that in a couple more lessons. Last example, folks, which is the tricky one of the bunch, and it's a fencing question. And if you ask the class here, they'd say, we wish we had studied this more for our unit test. Because it was one of the questions on your unit test, so make sure you're good with doing a fencing question. Suppose you have 40 meters of fencing. What does the 40 meters of fencing give you? It gives you the perimeter. And you've got to enclose a rectangular fence. Express the area as a function of its width. So all we're doing, ladies and gentlemen, is taking a look at area and relating it to width. So when we set up our diagram, we're going to use width. In grade 10, you may have used X for width, but in this case, we're going to use W for width. So what we need to do is say, hey, instead of using L, how do we get this expression? Basically, we go back to what we know about perimeter. 2 lengths plus 2 widths equals the perimeter, which is 40, and then we rearrange it to find L. L, after we isolate it, becomes 20 minus W. That's going to help us put it into our diagram here. And then, ladies and gentlemen, we know that area
Students
equals...
in Ms. Honer's class, please come and sign in at the office.
Apologize for the interruption. So length times width, guys, gives you the area, or width times length. And then you simplify. That's the expression of area with reference to its width. Okay? And then it said we were going to finish this next day, the B part. Basically, what you're needing to do is to complete the square. And after you complete the square, you understand that we get a vertex of 10 and 100, and that's this vertex here. Okay? So what does that mean? That means the maximum area of 100 occurs when your width is 10. But looking at your diagram here, you could have a width anywhere between 0 to 20, and you could have an area anywhere from 0 to 100. So to get your domain and range, you have to complete the square or find the maximum value on your parabola. And basically the width can be anywhere between 0 and 20, although the maximum is at 10. Remember, that's a symmetry point. And your range, which is your area, can be anywhere from 0 to 100. Okay, that completes this lesson, folks. Again, come see me if you need any help. Your homework here is page 35, numbers 1 to 3, 9, 10, 13, and 16 is a challenge question. Good luck.